Hi friends, welcome to follow up. Let's have a look at problem 146, LRU Cache, list recent used cache. In this video, we're going to give two implementations. The first one is based on ordered dictionary, and the other one is a full implementation based on doubly-linked list and hash map or dictionary. So here we are required to design a data structure that follows the constraint of a list recently used cache. So here we want to implement this class. Alright, so in other words, we are doing some object-oriented programming. So here, this LRU cache, so this is the initialization, right? So also we have a get method and we have a put method, so which are basically mimicking the LRU cache. So the functions get and put must each run in O1 average time complexity. So here are one example, and also we have some constraints. For example, the cache capacity is bounded above by 3000, and the key is in this range, and the value is in this range. In other words, so here the key value cache and the key and the value will be integers. So we can see there are sort of representations of some other objects. So here, at most 2 times 10 to the power 5 calls will be made to get to the method get and method put. So before we proceed to implement this class, let me make some comments on the plan. So as we mentioned at the very beginning, first we are going to implement for the current problem using ordered dictionary object. And then we are going to explain to you a full implementation based on doubly-linked list and hash map. So this is actually for general use. So with that said, we are ready to do the coding part. So this problem actually is it's very well known. It's either as a coding interview question or as a system design interview question. So here for the initialization, I'm going to introduce 3 fields or attributes. The first one is capacity, right? So it's the capacity given. And another one is a set. So this set will be used when we, in other words, when the cache is full, we want to implement some cache eviction policy. So this is the role of set. And how to start data. So here I'm going to use collections ordered dictionary. So the ordered dictionary actually is a subclass of dictionary, but it has some order. So in other words, it has some further functionality. So this is the initializer. So now let's look at the get method. So it's actually very important to notice that when we use this get method to a key, actually this key is corresponding to the latest used element. So this is very important. So first, if key in self data. So in this case, so first let's get the value. The value will be self data. So we retrieve this value, right? And then because this the key is latest used, right? So we need to first del this self data key, and then because here we are not doing eviction, so we need to put this one in at the end, right? So we are going to do self data key equals this value. So this part, these 2 lines of code basically tells that now I have accessed this key or key value pairs. I need to put this information at the most recent one. So here I'm going to use the tail as the most recent one, and the head as the oldest one. So then in this case, we can return the value. So this is the one. Another case is that the key is not in the dictionary. So in this case, let's return -1, right? This is the requirement. So this way, we finished implementing the get method. So now let's look at the put method. So in this put method, we need to consider 2 cases. One is cache hit, and the other is cache miss. So first, the cache hit. So in this case, it means that if k in self data, right? So in this case, what we want to do is self data. So the key will be updated to this new value if, and then we also need to put this key value pair to the latest. And so here we put it to move to end, right? So this is the one. Another one is cache miss case. In the cache miss case, so this is else block. So self data key, it will be the value. But in this case, because it's a cache miss, we input a new key value pair. So in this case, we are going to modify the set. In other words, increment this attribute by 1. So in the first cache hit case, it's impossible that the capacity is achieved. So in this case, it might be excess the capacity. In this case, we want to use cache eviction. So this is also where the least recently used name comes from. If self size is greater than self capacity. So in this case, we are going to self data. So we pop item. So we pop item from the very old one. So here we use last equals false, right? So in this case, we are going to decrement the size by 1. Actually, in this case, the size will be the capacity. So with that said, I guess we finished the implementation for this least recently used cache with the help of ordered dictionary, right? So before we move further, let's make a test. Yeah, it passes all the cases. So now let's submit. Yeah, it passes all the cases. You may wonder why we have this sent out. So actually, this is another implementation which we are going to explain. So now let's look at another implementation. So this one is based on ordered dictionary. So next, I want to give a full implementation using double-linked list plus hash map. So this is for general cases and not restricted to the current problem here. So for saving our time, so actually I wrote down this implementation a priori, and then the task here is to explain to you the logic. So this essentially playing the same functionality as we implemented here, but it's more general. So now let's explain that. So we have 3 classes. One is a node class, and the other is a double-linked list, and the third class is LRU Cache. So here, in order to distinguish with the problem class signature, I add a full here. So in this LRU Cache full, so we implement get and put method. So first, let me explain the 2 classes. So this node class is to be used in the doubly-linked list, and the doubly-linked list is what we used to store data. So in the node class, we have 5 attributes. So here's key and value and the count, and the previous and next. So each node, it has a pointer pointing to the previous node, and as also a pointer pointing to the next node. So count, you can consider it to be the number of key value pairs, if you like. So here is key value, right? So now in the double linked list, so we implement the main method is insert and remove. So here in the initializer, so we have a dummy head, it's node 99, this is for convenience. And originally we set the tail to be the dummy node. So notice that in the doubly linked list, we are going to use the tail as the newest used data, or most recently used data. And the size will be the number of nodes you can imagine. So here is 0. So though we have a dummy head, we do not count it, right? Because it's just a pseudo node. So this is the downed method length. Basically, we return the size of the doubly linked list. In other words, how many genuine nodes, like in this object, right? So now the main method is insert and remove. So let me first explain the insert method. So here we want to insert a node. So we just connect it to the tail, right? In other words, we use a tail to point to the current node. And then also we need to point using the current node should point into the previous tail, right? So in other words, tail pointing to node because node is next, and node pointing to tail because tail is the one before. Then we are going to update the tail. This is very important because the tail is always the newest used one. So this will be the current node. And then as we added a node, so we're going to increment the size by 1. So this is the insert method. So these 4 lines of code are very important. So you cannot delete any line. So because in other words, there's no redundancy here. So this is the insert method. Now let's look at the remove method. So we want to remove something. If we specified the node, we're going to remove that node. Otherwise, we're going to remove the oldest one. In other words, the node next to the dummy head. So first, let's treat some edge case. If self size is 0, right? In other words, we just have a dummy node, and we do have no node. So we're going to return none. And another case is if we are not given a specific node, what we want to delete will be the node next to the dummy height. So how do we delete a node? So we want to use this node previous, then pointing, right? This is the next to the node next. Then this way we will bypass the node. And then if node next is not null, then we're going to use the node next pointing the previous one, right? So node next previous will be the node previous, right? So this way we bypass the node again. So these 3 lines of code plays the role of deleting the node. Node deletion. So it's important to do this if block check because sometimes this node next might be null. So null has no method like previous, right? So after we did the deletion, then we need to update the tail because if the node we delete is a tail, then we need to point the tail to the previous one, right? In other words, if node is tail, then the self tail will be self tail previous one. So in this case, we need to adjust the size of the double linked list. So we're going to decrement the size by 1. Then finally we return the node. So this is the remove method. So this class double linked list is of general purpose. It's actually good to digest the logic, especially here the insert and remove methods. So with this double linked list class implemented, so we are ready to look at the LRU cache in full. So I saw some of the solutions in YouTube or in Leetcode. So typically we can see this solution here based on OrderedDict dictionary, but we didn't see a full implementation. So here we provide one. So now for the LRU cache full, so let's first explain the initializer, right? So we have a capacity. So this capacity is used to compare the size, and then if the size exceeds the capacity, we're going to implement cache eviction. So here we are going to have a node map. So this node map basically is pointing a key to the corresponding node. So this way we can access the node and do deletions efficiently. So the node list will be the doubly linked list. This is for storing the data actually. So originally I'm going to initialize the height and the tail to be some say dumb ones, node 00, node 00. And then we have first we want point height next to be tail and tail previous to be height. So this way we connect these two, right? So then we're going to implement the main method get and put. So the get, let's first see, this is the cache hit case, right? So if key is in the dictionary or in the lookup table, so we can get the corresponding node. Notice that here the key, the value will be a node, right? Then if we get this node, notice that this node will be the most recently used one. So we need to put it in the tail because the tail represents the most recently used one. So how do we achieve that? We can first remove this node. So because in node list object, it has method insert and remove. So we remove this node. And then we are going to append it in the tail. So it's node list insert, right? So this way, we are going to, what we return actually is a node value. So this is the thing. Otherwise, so here I didn't return -1 because it's a general purpose one. I'm going to return null. So this is the get method. So now let's look at the put method. So this method, so first we are going to consider the cache hit case. So in other words, the key is in the node map. In this case, first we get the node, and then we update the value to be node value to be this new value, right? So now again, this node corresponding to a most recently used one. So we make it in the tail. So we achieve that as above. So we delete first this node and then insert it. So after we insert, it will be in the tail, right? So this is the cache hit case. So the cache miss case. So we first create a node. So we have a node object, the key, the value, and then we are going to insert it, right? And in this case, we are going to update the node map. So key, this key will pointing to the node. So then also don't forget that we need to check if we need to evict the oldest one. So basically, we want to check the length of this node map. So if this length is larger than the capacity, means that it passes the capacity. So we are going to delete or remove the oldest one. So first, let's get the oldest one. The oldest one will be the head. It will be, how do we retrieve this one? So it's just next to the dummy head, right? So first we get the self node list. This is the data. So this is the doubly-linked list. So we get dummy head, and then we find the next. So this is node we're going to remove. Then we're going to remove this node, but we also need to update the dictionary, right? So in this case, we are going to delete this one. So after this deletion, so what we want to do, and actually, so that's basically about it, right? Because if you delete this one, so this length will be automatically adjusted later when you check again, when you do put input key value pairs. So that's basically about it. So if you compare these two implementations in the problem here and in the general case, so actually the ordered dictionary is backends by doubly-linked list, right? So this is just using some known implementation of ordered dictionary. So here we just implement from scratch. So we implement doubly-linked list and then use that as a container to do the LRU cache in full. So here, this is some just initialization and print and check that. You can also do this check. So with that said, I guess we finished the two implementations. So actually, it's good exercise to digest and practice or write by yourself. With that said, I guess that's about it for this video. Thank you.